19. We need give a couple minutes for other people to join us. Let's see. So Ryan Sturm, you're outside? Looks like you were walking or something.
Yeah, sorry. I'm just getting my girlfriend some shovels because she's gonna work on the garden.
You're some what? You're getting her what?
Shovels.
Shovels.
Why not?
What's that for?
Gotta bury the dead body, you know? No witnesses.
Sounds scary.
I am not burying dead bodies. Come on, we have high.
Dude, that's exactly someone. Come on now. That's exactly what someone would say if they were doing it. No, we're just gonna plant some trees.
All right, it's good time to plant the trees, I guess. Yeah, actually, it's pretty good. It's a fall, and then we had a rain, so the dirt is wet. Yeah, it is a good time. Yes, that's it. 21 students. We're supposed to have 26. All right. So first of all, I want to thank Nicholas Broom. He's very, very kind. He recorded our lecture and then he posted on a YouTube channel. So whoever needed to watch, you can watch that. And he's planning to do this for the rest of the semester. It's really, really nice of him. Usually I do it myself, but somehow since I changed to a new computer, my computer's freezes every time when I do that. So it's very, very nice of him. So that's very nice, you know, nice person. I've known him for, I don't know, a year, right? He took, I think he took 110, he took 148, he took a 218 in the summer. So he's a very nice person. So I'm very thankful.
Hey, yo, Nicholas, you're godly for that, bro.
Yeah, very nice. We have a lot of nice students, right? That's really something I'm grateful for about, and then it's whatever gets me going, because when I have students like that, it shows that they are engaged, they are interested, they are participating. Okay, the worst kind of class is nobody cares. Then it really bring down my mood when I know that you don't care. Then I kind of start to question myself: Am I doing this for anything good? Am I doing this, helping anyone, or is it really making any sense doing this. So every time when I think about retirement, this is something that actually get me going when I see you guys are interested. And every week or so, I get an email from people, from past graduates. They email me when they doing well, and so I'm very, very happy whenever I see those emails. So thank you, Nick. Good job. Okay, so any questions about the assignment? I asked you if you need the extra time. If you needed the extra time, you could have extra time, right? This is a course, there's really no point to rush. I do want you to kind of wrap up whatever you learned before. So this way you have a good closure, right? If there's anything you think like you need more time to learn, and we can do this in this course. In a way, this course doesn't really have a definite goal, right? We do have some objectives, but those objectives are not required by other schools. Okay, it was by Stony Brook, but then they found it was over. It was like too much for their students, so they kind of watered it down to another course, which is the CSE 216. It used to be the CSE 219, which is kind of like a software engineering course, but then they found it was too hard for their students. But we never really changed it, so we still have our 248 that is kind of software engineering. But because Java gets more and more fancier, so I realized that we have some holes in our knowledge. So I decided to slow it down, trying to fill the holes we didn't get to do in the past. But only when we are ready, we're going to move to the software engineering part. Okay, like a new topics. So that's why I wasn't rushing. So if you do need extra time, you do make sure you work on it. I think that will be a good time to catch up, right? I just got a couple students emailing me say they need extra time, but the rest of you, if you do need extra time, make sure you work on it. Now, there's a few things I do want to cover. I think we never really get chance to cover. First of all, I want to expand our discussion about functional programming, because that's like a bridge between Java and some other functional languages. Okay, so some four-year schools like Cornell, they have a whole course on functional programming. Okay, so some other schools may just touch upon. So I think it's very important. So that's why I would like to discuss a little bit more. And then I want to talk about another topic. It's called streams. Streams, that's very important. You will see how interesting that is. Okay, so I'm going to give you some examples, and you will see the importance of it. Obviously, we don't have time to cover everything, but I think we have time to at least talk about and give you some examples. So then you can you can read upon yourself later on, right? So at least you get some introduction. All right, so I'm going to talk about functional programming first. Okay, we did talk about it when we were talking about lambda expression. We said a function can be treated as an object or treated as data, because object contains data, right? Chris, you okay? So you must be talking to Cody because Cody is smiling at the same time. So Cody's always happy. So you don't want to get him started. Okay, so so the example I gave was when I had like a sort method. I don't know if you remember the sort method. So I have an array, I want to sort it, or I have a list, I want to sort it, right? Remember you have a collection start sort or array start sort. Remember those? Right. So if you don't, then I'm going to remind you. I'm pretty sure most of you have no clue. So I'm going to just remind you what I was talking about. Okay, so I have a package called P0, and so that's just the intro. Okay, so in that I talked about how to sort. Right, we just talked about collections. We talked about algorithms. So, for example, I have a demo. Oh, I need to
We can't see
you
your.
my. Yeah, I just realized that. Thank you. Yeah. Okay, now you can see, right? Okay, so here's just the main, and remember I can sort arrays, right? So for example, I could sort things like I just kind of create an array. So I can even say integer array. I can say array or just the array. So equals. So I can do something like a 1, 2, 3, 4. No, I don't want to be like this. I want to be like a random, right? So 2, 30, and 14. So I just have an integer array. You can see that, right? So I want to sort it. So you know how to do it, right? So you can have say array stop sort. Okay. You could also have a parallel sort. Parallel sort means you can have multiple threads to sort it. When the array is big, say you have hundreds of thousands, millions of items, you can do parallel sort. That means you can have multiple threads sorting them at the same time simultaneously. So in other words, you take the whole array, you break it down into subarrays. Okay, say there's a million array, you break it down into 5 subarrays. Okay, so each subarray is like 1/5 of a million, right? 200,000, right? Then you can do parallel sort. That means you're going to sort the 5 arrays simultaneously, and then you sort those 5 arrays again. Okay, it's like a merge sort. Like that, okay? So that is more efficient, faster, right? Because you're sorting them all simultaneously, 5 smaller arrays simultaneously. Okay, that's because of multi-threads. We're going to talk about that at some point. But for us, we can just focus on sort rather than parallel sort, right? So at some point, we're going to talk about a parallel sort. Now we can talk about a sort. And then we can sort an array like that, right? We can sort an array like that. So then you can display the array. Okay, you can display, so you can say array start to string. Okay, then you always give me this deep to string. To string, I'm sorry, to string. And then I'm going to say ARR. So that will be the sorted version, right? And then if I display it will display the sorted version. You see the sorted version? So that method, right? That method sort is an algorithm that will sort an array, correct? And also I can do a list. Okay, so I have a list. That is an interface, right? Right. We talked about a collections framework. One of the 3 interfaces, one of us was list. Then there's the second one was a queue. The third one was set. Right. They're all underneath the collection. interface, right? So this is one of the interfaces. Because of that, so this could be used as a data type, right? So now I can say integer. So this is generic, right? Integer, and then I can take make this a list. Sorry, make this a list equals. I can say, remember I have an array, right? See that array? That was my array. See that? And then I can say as arrays. I'm sorry. Dot as list, and then as list I just put the array in there. So now I'm turning this to the. turning this into a list. Sorry. Hold on. Let me just get the whale in. Okay, someone else came in. All right. So the array I had. Okay, the array I had. So I'm not going to sort this anymore. So that's one way of sorting it, right? Now I'm going to I use that unsorted array. This is the unsorted array. I turn that array into a list. Okay, so that's the array. I turn this into a list. That's why now I have a list, right? So if I just display the list, you could, right? So just the list. So you just display the list. The list is not going to be sorted. You see, just the original 10, 2, 30, 14, right? That's the same thing. Okay, but that's not sorted. But I can sort it. Okay, to sort it, I can just say collection. Remember that? Collections dot sort, right? So I can do the same thing. So I can sort. Now sort, I can sort the list. Okay. Now once I sort the list, I can just display the sorted list this time. So they should be sorted now. You see, they're sorted. Correct? Okay. So this is easy, right? This is easy. And now, what if you don't have those primitive ones, or this? The reason we can sort them is because we're using the comparable, right? Remember, all these are the integer type. There are a subtype of the compare. They all implement comparable interface. Remember that? Do you remember the comparable interface? That's how we compare, right? So if you don't remember, you can Google comparable. I think I showed you before. Let me print out another page here. Okay, so I'm gonna grab it here. So I'm gonna just search for comparable. Right, so that's to the Java comparable. So I'm gonna bring that one in. And then these are the things that all subclass. No, we can't see it. I'm gonna bring it over here. All right, so here are the things that implements comparable, including integer here. You see the integer? Okay, that's why we can compare them, right? Because they are they all implement comparable, correct? So we do not have to say anything because they already implement comparable. So we don't have to add a comparator. Okay, so if this is something that does not automatically implement a comparable, like a student person, then we have to do comparable, correct? Comparator. So say you have a student. Let me see if you can find a person. Here's a person, right? Here's a person. So I'm going to create some person. I'm going to comment all of this out. I'm going to create an array this time. So array. I'm going to go to person. So I have a person class. That's a person, and I'm going to create a person array. So that's array. I'm going to ARR, right? Equals new. No, I can just put a person inside if I want to, right? So I'm going to say new person, and then the first one is a name is A, and then person I think has a GPA. Has a GPA, right? So it has a GPA, so it's like a 0.5 about the student. So I have another person. This time the name is B, and the GPA is 1.5, or make it kind of random. So 2.5, and then this one is a Z. So it's different. Let me import the person first. So import from P1, I kind of copied before that person. Okay, the person's over here, I think. P1, that's a person. That's my, okay. So so I imported the person from P1 person, which is P1 person. That's the person. That's the class. Has a name, has a GPA. You're familiar with this, right? So I'm back to here. Okay, so I have two, and I'm going to third one. New person, and then I have something like M. Okay, so GPA is 3.5. Okay, or 1.5. Okay, so this way they look like random, right? Let me close all this. All right, so now I created an array. The array has only 3 elements inside, right? Okay, but if you look at my person class again, I don't need this one. I already have a I implement a comparable, right? Already implement that. That means when I compare them, when I sort them, it's going to be sorted by the GPA, right? Going to sort by GPA. Okay, so let me go back in here. Now I'm going to sort it, right? So I'm going to say array start sort. What I'm going to sort? I'm going to sort ARR. Okay, I'm going to sort ARR. Okay. Now I'm going to display the person. That will be array start to string. Okay, then I'm going to say ARR. So this will be the sorted version. I'm going to display the sorted version. The unsorted version, is 0.5, 2.5, 1.5 in terms of GPA. So that's not sorted. That's not sorted. So I'm sorting it. And when I'm sorting it, I'm not specifying anything. I'm not specifying a comparator. That means I'm sorting by GPA, because that's how I implement my comparable, right? That's a comparable. See, I implement a comparable. So I would expect my objects will be sorted by GPA, right? So when I display it, it should be GPA, correct? So let me just show you. And 0.5, 1.5, 2.5, indeed, right? Sorted by GPA, correct? So we know that's okay. Now, what if I change my mind? I want to sort it by name, right? And one way, of course, is go to person, you change it. Okay, you change it to sort by name. So you disable this one, you enable this one, right? Now it's sorted by name. So name compared to, because it's string, you compare to name. So now we're sorting by name. So I'm going to run this again, and then it tells you, oops, why is that? No, that should be fine. Let me say person compared to name. That's cool. Nothing wrong with that. Then I'm going to say Z, sorted by Z, B, M. B should come.
I think it's not the right person class. It's in the other package.
Okay. All right. Thank you. Let me close all this and then start from over. So that's the package I want. Person is in the P1 person. I'm sure you're right. So P1 person is this one. So I'm opening the right one now. Okay. So now I'm still GPA. That's why. So I was working on the wrong one. So I'm going to enable the correct one. Now it's sorting by name. Okay. Now I'm going to demo. Yeah. So let me run this. Like sorting by B, M, and Z. Correct. So now I'm sorting by name. However, though, you're not supposed to just go into the person class, make changes, because once you create the person class, the class may be used by other people. You cannot really make a modification like that. So we're going to go back to what it was. It was like this, right? So that means we need to introduce a comparator to do it, right? comparator. So the way to do it is just say you need a comparator. Basically, you need a new comparator, right? The comparator allow you to define how you want to sort it. Okay. Now, comparator is an interface. It's not a method. It's not a class. You cannot create object out of a comparator. Do you remember this? We talked about this before. So now you're gonna have to create a comparator object. Are you okay with this? So I don't know, because we talked about this before. I don't know if you remember, because it seems like you may not, because I have no feedback from you guys. Do you know what I'm talking about? Do you want me to break it down even further? Because otherwise, I'm gonna have to write another class to implement comparator, right? You okay? Do you need that, or you don't? If you don't, I can just write it from here, because now I can basically just have another way to do it. So I just say import comparator, right? Now add implement method. See, that's another way of doing it, right? So just object one dot compare. Okay, object one that is, oh no, I need to put it down the new comparator. I need to put it down this as person. Let me do this over again. Let me do this over again. So new comparator, and then I have to implement it, and then this is going to be. Okay, so let me see if I can implement the method. And then now I'm actually implement method. So that's O1 dot compare to O2, O2. And then O1, I want to do by name, right? O1 dot get name, compare to O2 dot get name. So now I'm comparing by name. So I'm imposing a new rule onto the sort method. Okay, this time I introduced a piece of data here. Basically, it's an object. Okay, it's the comparator object. Can you see this? Okay, so basically now we're introducing an object, right? What object is a comparator object? The implementation of this is the method here, right? Compare method. So we compare name, one object to another name. So now I'm comparing by name. It was comparing by GPA, right? So I'm comparing by name. So when I run it, you will see now is B, is M, is Z. So I managed to compare by name, correct? All right, so this is still messy, right? Because you can see it's still messy. You have to create an object of an interface, but interface, you cannot create an object out of interface because it's not concrete, right? It's abstract. So what you have to do is you have to create a really anonymous class in there, and then the class just has no name, so you cannot really name it, but all you care is it has the compare method. Okay, so you implement the compare method, and then you just return, you take the two arguments, you compare the name, and then return the natural order, and then now you do it by name, correct? Okay, so that's one way of doing it. So I'm gonna comment this out. I'm gonna do the second way, right? The second way is arrays dot sort, and then I don't want to do parallel. It's so easy. So, and then this is the first one is array. Okay. Now I need a comparator. Now this time I'm going to use number expression. Okay. Without specifying all the details. So all I need is I need parentheses. In the parentheses, I'm gonna have O1, O2, right? O1, O2. Okay. Now I'm gonna say number expression. Then that's gonna follow by the method's body. Which method? Compare method, right? Because that's the only method, right? Because it's a functional interface. The comparator is a functional interface. It only has one method to be implemented, so that it has to be the compare. So I just need the body. So I could take this body. See, I take this body and I post it over here, and that is the return 0102. I think that's correct. So 0102, that's return D1, get the name. We may have to take 01. Hold on. Did I get an extra one there? Expected. Okay, return. I need a curly brace. I'm sorry. I need a curly brace. So that defines the body, right? Defines this, and then ends here. Okay, so that get a name. I may need another one in front of it just to match it up. Okay, so insert semicolon. So that's the body. If you want to split it a little bit more, maybe you can split it like this, easier to look. Okay, so now, okay, so that is the other way of doing it. There's another way of writing it. Okay, so in this simplified representation, you don't have to say compare, right? You don't have to say compare because that's the only method. So this body has to be compares body, right? And you don't have to specify a class of the comparator because the sort method requires a comparator method, a comparator object, right? So this is represent the comparator object that the sort is expecting. Okay, now what is this? This is a function, right? This is a function. You give me two pieces of data, two object, and I'm going to return a value. So that's the function. So now function is used as an object. What object? In this case, comparator object, right? And that's all used as data. In other words, the function is used as an object. Since object contains data, is data, so function is data. Okay, and we pass that to a method. Which method is this? Sort method. Okay, so that's so this way we can sort it by name. Now, if I run it, it will give me the same result of B, M, and Z, right? So it worked out. So this is much more concise, much more concise, much more concise than even than this one. That's even much more concise than another one. That is, you actually implement a separated class for it. Okay, you could just implement a separate class because I don't see a lot of. Let me close this so I don't get confused. So I'm going to implement a separated class. That's even worse, right? So I'm going to implement a class. I'm going to call this called my comparator, and my comparator class, it implements comparator, and then it's a person type. Okay, so I'm going to import a person. What the hell? So import a comparator, and then import person. Okay, now you have to implement the method. Now this is like, right? See the compare method. Now you're going to say return 01 dot get a name, right? Dot compare to 02 dot get a name. So that's just like a total implementation. That's a complete implementation. right? So now I've created even a new file, a new comparator class. Okay, now if I want to use this way, let me go back to demo. This is the most awkward way I could show you. So I'm going to comment out this way. I'm going to do that way. That was even worse, right? So I'm going to do that. So my comparator, okay, and class, I just say comparator or comparator one equals new my comparator. You see, now I created my comparator. Now, if I want to sort, I just say arrays dot sort. Okay, still getting the parallel sort, and then this is the array, right? And then I put comparator in. That's my comparator one. So that's another solution. Now this time you're going to sort by name because that's how I implement a comparator, my comparator, which is sorted by name. See that? Okay. Now I can run this. It's going to be sorted by name also. You see, BMZ as well. Okay. So I have three different of implementations. This is the first one. That's the most tedious, right? Because it involves creating a new class, create a new object, hence a new file. That's my comparator. Or I can do the anonymous class. This is another one, second one, which is better, right, than the my comparator one. You don't need another class because the other class is anonymous. The method is implemented in place. Okay, and the third one is just the random expression, just like that. Okay, which is the most concise. Okay, all three ways are the same. Okay, it's just the third way is the most the one numbered expression one is the most concise one. Okay, so this way, when you want to sort it differently, you can sort any way you want in here. If you want to sort by, I don't know, say you have a phone number, you want to sort by a zip code. If you do have those, you can sort it in the last minute when you want to actually sort it. So you can delay the decision. So you don't have to create your separate class ahead of time to decide how you want to sort it. You can just sort it at the last minute when you actually want to sort it. Then you can decide how you want to sort it here. Okay, so the key is here. We are able to pass a function into the sort method. See, that's what I highlighted one. That's the key part. Okay, and we treat that function as data because it's object. I treat it as object and treat it as data and give it to a method. Okay, so that is the important part. That's the important part. So now, do you have any questions? This is the part is really review. I don't know if we can do the same for the list. Remember the list for the collection start the sort. We can do the same thing. Yeah, generally yield.
It will be the same for the list, right? Because it's like it implements the collection part, isn't the list?
Yeah, of course. Yeah. So I can do it right here. See, if I want to do a list, first of all, I'm going to create a list first, right? So I'm going to create a list, and to create a list, I'm going to say, I'm going to put it over here. I'm going to put it over here. Okay, so that's a list now. So I'm going to do a list. So list, that's a interface, right? Okay, so now I'm going to say person type of list. I'm going to call list. Do I have a list already or I don't? I don't have a list. It was commented out. So it's called list. Equals, right? So I'm going to say arrays as list. Okay, which one? I want to have my ARR. That's my person array, right? So now that the person array I had, I turn it into a list now. Of course, you can create array list. You can add them separately. You can use a linked list and add them separately if you want. Okay, as long as as long as I have a list, in other words, I can use the collections. Okay, so now I'm using collections, right? Collections dot sort. Okay, collections dot sort. Now I can sort the list. As is, when I sort the list, is based on the GPA, right? Because that's a comparable I had. Original comparables by GPA, correct? So if I want to sort by something else, by name, then I can just say the same thing here, right? So comma, I need a comparator. What is my comparator? This is my comparator. See, 2. This is my comparator. Okay, so I'm going to copy this. I'm going to put it over here. I'm going to get rid of all these 2. So that's my comparator. Now I'm sorting by name. Okay, so once I've done that, I can just say print out the list. When you print out list, it's easier. You don't have to say arrays or anything, because the list will print out every single element of it. Okay, so now you just show the list. It's a B and Z. See, it's sorted by name, not by GPA anymore. So it's the same. Okay, again, we are passing a function. We're passing a function. The function takes 2 input, which we put in the parentheses. Okay, and then we return a Boolean, right, whether it's true or false. Okay, we return a number, an integer actually, return an integer. So that tells us how we sort it. So that is something you really need to remember, right? The new way of doing things, that you can pass function to a method. Okay, so this is just a intro. Okay, there's lots of other applications. So I'm going to show you another application I did earlier today. Because we're familiar with this, so I'm not going to, we don't have to print it out. I'm going to upload the code for you because we did this before. Now maybe you understand it better. Okay, so one function is called a predicate. Okay, it's like a functional interface called a predicate. Okay, we did this when we did the search method in a bag. I don't know if you remember that. So I'm going to show you the conventional bag class, right? So this is my bag class. Okay, here's my bag class. I have a person bag, right? The person bag has a person array. You see that? Okay, and then I have n elms to keep track of how many how many person objects I will put into the array, right? Okay, then I have a maximum size. So I made in the constructor, I build the person array, right? ARR, see? I also made the maximum size visible to the whole entire, to the entire class, because that's an instance variable. It's blue, right? The maximum size, you see, it's blue, so made it visible. You got it? So there's nothing new here, really, right? Nothing new. And then I wrote an insert method. There's nothing new there either, right? So I take a person, I insert into the array, and then I increment n elms. So nothing new, correct? I wrote a display, which is also nothing new. So there's no need to repeat that, right? Just display every single person in the array. Okay, we cycle through, right? I is 0 all the way to n elms minus 1, basically. Correct? All right. So here is the key part. This is a search method, right? When we were doing 148, we just say search by name, search by ID. So we had to write multiple search methods, right? We have to decide how you want to search it. If you want to search by ID, then you have to search by ID. If you want to search by name, you have to write a separate by name. So now the new way of doing is I don't want decide. Instead, I want to delay the decision. all I want to put in is a predicate. What a predicate does is that's a predicate. It's just like comparator is interface. Is an interface, and the interface has one method unimplemented, and the name of the method is called a test. Okay, is given. It's built into Java API. Okay, so there is a interface called a predicate, and has only one method unimplemented. Hence, we call this interface functional interface, right? Remember the definition of functional interface is you have an interface that has only one method is not implemented. Last time was comparator. The only one was compare, right? Remember that? Compare to. That's the compare, that was the only one, right? But this time is test. The method's name is a test. Okay, that's why we call this a functional interface. Okay, now the variable name I call the tester. You can call anything you like. It's just an object of the predicate type. But again, predicate is not concrete class. Instead, it's just interface, just like a comparator. Okay. Okay. So basically, all I'm expecting when I'm writing the search method, all I'm expecting is to have a predicate object, which I'm not specifying at all. I'm delaying the implementation of that test method. All I'm taking in now is I just want a predicate object without actually implementing that that class, without actually implementing that method. But I do know, though, the test method returns a Boolean. That's all I know. I know there's only one method is called test. I know that method returns a Boolean. I know the method takes in one argument. That's all I know. Okay, but I'm not implementing it. I want to delay this because I have to wait until I need the search, then decide whether I'm going to search by name or search by GPA. Okay, I'm going to delay it. In other words, you okay? Good, right? So I'm not implementing it. So all I'm saying, just a placeholder. It's called a tester. Okay, so the tester has a method called a test, right? Remember that's the object of the predicate has a method called test, and test will take one argument. See, in this case, is a person object at location I. Okay, so I'm going to test that person object, and since it's in the for loop, so I'm testing every person. I is 1, I is 0, I is 1, I is 2, I is 3. So I'm testing every person one at a time. That's the key, right? Now, once I test, because the test method returns a Boolean, right? So if it returns true, that means then we're going to take that person object at the location I, I'm going to put into another array. And the other array I just created called a person array type is I call it result array. That means we found a match. So whenever we found a match, we put that person into a new array to store it. Right? The new array size is the maximum size. That means even if the original array contains every single one matches, then I'm going to return basically a new array contains everybody, right? That means I need the size to be maximum size in case every single person matches the criteria. Right now, I don't know. I don't know how you're going to test it. I don't even care. I'm going to delay that implementation. But there's a possibility every single person matches. You cannot eliminate that possibility. So that's why I'm making a new array as big as the original array, as this one. Okay, just in case everybody matches the criteria, right? Test true. So now, so I'm just keep on doing this, right? So finally, when we finish the for loop, that means any person matches that criteria, the search criteria. What is criteria? I don't know. I haven't specified it. All I'm saying, I'm going to test it. How am I going to test it? I don't know. I'm going to implement that later. a delayed implementation, right? And then, but I do have the test giving me an if, and if it's true, I'm going to add it. So when I'm done, I'm going to return that result array, but only return the part that contains the match. I don't want to contain the whole maximum size, right? In case you have no match, or you have one match or two matches. So I want to copy only the part with the n size. That means the amount of actual matches. I want to copy that part, create a new array, and return. The rest I'm going to discard. I'm going to abandon. All right. So that just set up a framework really to run a searching method. So you cannot use this method as is, right? You're going to have to provide a function there to allow you to test that returns a Boolean, right? You have to, because that's required for the searching method to have a function here, just like we did operate comparator. Okay, but I'm not actually implementing until I am doing the demo. That's when I'm going to implement. Okay, all right, here it is. So I have a person array back. That's just back I just created. Maximum size is 10, right? Okay, then I insert the 4 person objects into the bag. Okay, just for random objects. So you see the names A, Z, and B. The GPA is all random. Okay, now I'm going to do the search. You see the search? Array back search. Okay, I'm calling the search method now. But the search method takes a predicate function, right? Remember predicate? So here is what I'm putting into predicate as a predicate implementation. Oops, sorry. Okay, remember that test method takes in one argument? That's the P. I call the P, could be anything. You can call X, Y, Z, whatever you want to call it. The point is one argument, which matches that person object when we did the back. It matches here. One argument is a person, one single person. Okay, so imagine one single person. Now I just happen to call it P. You can call anything like X, Y, Z, as long it's just one. It's one. So what you're going to do is you take that object, in this case, the person object, you get its name, you compare to B. That means you're going to search for B. If this returns true, if this returns a value equals to 0, that means it's B, or anything bigger than B. So you can find a name that's bigger than B, equal or bigger than B. So who's bigger than B? Z is bigger than B, M is bigger than B, B is equal to B, right? So you're going to suppose to find all 3 objects, these 3. They can be returned into an array, okay? So now you're going to print out that new array that contains Z and B. Okay, so I'm going to disable this for now. Display all this rest for now. So I'm going to get there slowly. Okay, so just look at the part I just showed you. Okay, so you are saying let's create a bag. Let's put a bunch of people in there, person in there, right? Person objects in there, and now I do a search. When I do the search, at this moment, when I actually do the search, I decide how I want to search it. In this case, I put in a predicate object in there, and the predicate object basically is the implementation of the test method, and test method takes in one argument, which is a P, a person, and it has the compare method. So you have to say compare to. So that's the body of the method. Okay, so I just run this, and then you can see Z and B, those 3 objects that matches this, right? Okay, if you want to see a simple version, I just say equals equals. So that means the person's name happens to be B. So obviously you're searching by name, right? Searching by name, and you'll return whoever named B. So there's only one person with the GPA is 1.5, right? So let's run that, and you should find that B GPA is 1.5. You found it. Okay. Now, if you say I want to find everybody that has a name of B or bigger than B, then you can grade them because you as long as you return a Boolean, is fine because that's all test wants. Okay, now I run the same program. You will see now Z gets returned, M gets returned, B gets returned, but A is not returned because A doesn't meet the requirement. Right? Does that make sense? So that is that's like a last minute. I decide I want to search by name. Now, if moments later you want to search by GPA, then fine. Just use the same search method, right? And then you take the one person, right? And then you're gonna say this time you can implement the method that is compare, that is get GPA. You say I want everybody who has a GPA of 2.5 or higher. If you just want 2.5, then just 2.5 because it's Boolean, so equals equals. And then you should return A, that object, right? So run it, you get A, see? But if I want everybody that has GPA of 2.5 or higher, then I will get, see, A has 2.5, M has 3.5, so that matches. And A and Z, I mean Z and B do not match, so they don't show up. Again, you delay this implementation. Okay, so if you want to say anybody that is less than 2.5, you can do that too. Okay, the last minute you decide you want to last less than 2.5, and the only person you found was Z, Z and B. Z is 0.5, B is 1.5. So both are less than 2.5. So you found them. You see the flexibility? Right? Because you're delaying the decision, you're delaying the implementation. So you don't have to do this in the back class. Okay, all you have to do is tentatively, all you have to do is to put a function there. Say, I'm not, all I need is a Boolean test. That's all I need. And I'm going to implement that later. So that gives you all the flexibility. So your back class will be much simpler, and your demo will be much more flexible. Okay, so that's another example of sending in a function as an object or as data to a method. The method in this case is search. Okay, so that's pretty good, right? That's a very nice implementation. You can see the benefit of using using functional programming. Okay, again, the requirement is the predicate can only have one method, right? The only one method, and so that's the test method. You can only one. It returns a Boolean. Yeah.
So just so I understand, when trying to use the lambda expressions, in this case we use predicate as the function that we're passing into the lambda expression has to only have one method, or it's just this case that for predicate it has to be one method?
Right. Predicate has one method.
But if it is another method, another function,
you cannot pass as a function. You cannot pass like this. You cannot. You can only take functional interface, which means definition of that is the interface has only one method, is not implemented. That's the definition.
Mm-hmm.
Okay, so this is one. The method's name is going to test, returns a Boolean. That's why you can use the if statement, because you know it's going to return Boolean. But you don't know how to implement it, but you do know it's going to return Boolean. So that's why you can put in the if statement. Okay. Now, if there's a interface that has more than one method, unimplemented, then you cannot put it inside the argument. Or cannot use it as an argument, in other words. It has to be a functional interface.
Okay.
Like a comparator is one also. This is the one. There are tons of others. So we can spend a day talking about different kinds, and they are all these function interface are in a library called Java util function. Okay, that's the library contains all these function interfaces. This is one of them. Okay, predicate is one of them. Then there's a consumer, there's a function, by function, the supplier, the many commonly used functions. Okay, so that's just another one. Okay, all right. So I'm going to show you. I'm going to show you another one. So so here I'm going to show you another implementation of this. Okay, another implementation is a class called person bag array list. Okay, that's just another implementation of a bag, but this time I'm not using array, I'm using array list. Okay, so this bag using array list rather than array. Last time I'm using array, this time I'm using array list. So all you don't need an elms anymore because it knows to expand on its own. And so you have a person array list and you create a list. Okay, create an array list. See, type is person. You create the array list and then add a person into the array list. Just use the method add. Okay, and then this is a search. So I'm going to search through the array list to find some person objects. But I don't know how I'm going to search. Again, all I pass in this new method is called a predicate. All I'm saying, I'm going to pass a predicate in there. Okay, because I know this predicate function interface has a method called a test, right? So here's the test. So what it means, I'm going to take the list. I'm create another array list that's going to hold the results. Okay, just like the array result array before. Okay, so I create a new array list, and I'm going to go through each of the person in the list. So for each. Okay, and then I'm going to say for each person, or I can say P or S, whatever, I'm going to test that person. And if it turns true, see, that's the Boolean returns true. If that test returns true, then I'm going to add that person into the result list, into this list. Then I'm going to return that list. Okay, so I have no N or N elms to worry about because I'm using array list. You got it? So that is an array list implementation. Now, once I have array list implemented, again, you realize I haven't decided whether I'm going to search by name or search by GPA. I haven't decided yet, again, right? All I'm saying is I have a placeholder called a test, but I don't know how it's going to be tested. I delay that until here. So now I'm creating the bag array list, you see? I'm going to add them into I'm going to enable this now. Okay, I'm going to add those bunch of person object into the bag. This time is the array list bag. Okay, once I add them in, you see A, B, C, D, and then this is their GPA, right? I put it in, and now I will do search. Okay, the search method, the method takes in a predicate, and the predicate has a method called a test. So here's my test method. We're taking one argument. Test method takes in one argument, returns a Boolean. Okay, the Boolean is you take every person, you get his GPA, and you test if it's greater or equal to 2.5 or not. If it is, then that's true. If it's true, you add to that the result array list. you're going to return that, and you're going to display it. Okay, now if I run it, then you get everybody who has a GPA greater or equal to 2.5, which is C and D. The other people, they are 0.5, 1.5, they don't meet the criteria, so they don't get picked up. Okay, so if you want to find the people who has a GPA of 2.5 only, then just 2.5, right? Then you're going to return one person that's a C. See? Okay, you can do the same for by name. You can do same thing like we did before. This is the by name, so you can do this by name. Okay, so so that's it. That's it. Okay, so that's a good example of functional interface or functional programming. Allow you to delay the implementation until the last minute. It gives you a lot more flexibility. All right, any questions here? Any questions?
So when you do the tester.test in the in the actual search method, it's basically just taking your predicate and performing whatever's written in like the argument here for your search. When you call the search, how you have like that p return, saying tester.test is referring to that.
Right. See, when I do search, right? You see search? Search requires a predicate object, right? Remember that? Okay, let me write differently. This is the same thing we did before. Okay, I'm going to comment this out. I'm going to do this differently. Okay, I'm going to do something like this. List result list equals the list bag dot search. So what's inside there has to be a predicate. Okay, that is the predicate type. Right? Now predicate, we can write it more complicated, something like this. New, I need a predicate object, right? Tester is the predicate object. New predicate and person. Okay, so that's predicate. And now I'm going to implement, but I cannot do just like this because predicate is not a concrete class. I don't have a constructor to do this. If I did, I could just do this way. But I don't. So I just have to implement the predicate interface. So all I have to do is put a curly brace there. You see, curly brace there. Okay, I hit enter. Now I can import this predicate and make sure you pick the second one, java.util function. Make sure not the other one, that's SQL, not that one. Do that. Okay. Now that tells you you have to implement that test method because that's the methods I implemented. Okay. So now there's a test method, right? So when you implement the test method, you're going to return something. What are you going to return? We're going to return this one, right? So we're going to return P GPA greater than this. So I'm going to take this one. I'm going to take it into here. Okay? As long as it's equal to 205, it's going to be returned. This is like a person, so I'm going to put a P there, and then that's fine. Okay, so now what do you see? You see the comparison of the two things, right? Here you see the P, this P is this P. It just says the test method requires one argument. The argument is P. If you want to look at it nicer, you can even put it inside parentheses. So that matches this. Say, okay, I need one argument with the person type. And then I need the body of the method, which is this. So which is this. I put it in there. So you don't have to specify this stuff because this is known is a test method. That's the only method. You don't have to specify anymore. Okay, so those two are equivalent. Or you can even do something like this, crazy, right? So you can create another concrete class. Okay, create class. You're gonna call my predicate. This is the most tedious one, right? My predicate. And the my predicate, you can say implements predicate. That's the most awkward one, right? So you have a person, okay? So you're gonna import a person. I'm gonna save this. Predicate so I should what is this? Predicate, I'm importing predicate first. So make sure it's Java util function. And then you can import a person, okay? So now this is my method is not implement, that's a test method. There you go. And I'm gonna delete this. And then you're gonna do the same thing. You're gonna return, I have that as P, right? Or it can be T, doesn't matter. And then return that, get GPA. Now you decided. So you're committing yourself now. You're committing yourself, you're gonna use GPA. You're gonna search by GPA. And the criteria is GPA has to be greater than, equals to 2.5. You're committing yourself. Okay, now you have a separate class now, separate file called my predicate. Now when you go back here, not the demo, then you can disable even this one. You can disable this one. Now you can do something like this. You say list result list equals the list bag dot search. Okay, now you need a tester, a predicate object, right? So you say new my predicate. That's it. But you remember this time you commit yourself how to search. You wrote an entire file called my predicate. You wrote the entire file, and then now you just use create object. So this is again just like a comparator. This is the most tedious one, right? This is less tedious. This is the most concise. Same like last time. Okay, so this P is this P. Okay, this P. And this P is really this P. Okay, I'm gonna do this. So my or just predicate person P equals new my predicate. Okay. Now you just do it this way. Okay. So this is most tedious. Okay, so now you understand this is the easiest one because you use the number expression. Okay, good. So we won't, you guys okay? It's a little bit convoluted, but I don't know if if you could follow. Right, you
Yeah.
okay?
Yeah, good.
Yeah?
Yeah, sorry. I'm not sure if it's just me, but I keep getting your audio cutting in and out. It might be just me though.
Yeah.
Other people, you have the same problem?
No, it's good over
No,
here.
no problem. It's good.
Then
Yeah,
Ryan
we're
too.
fine.
Sorry. Get a better speakers,
Get better internet.
maybe better internet.
Yo, just check the YouTube either later tonight or tomorrow morning.
All right, so you're going to see a lot of those. So I'm going to see if I can show you java.util.function. That's the library. Okay, so let me see if I can take you there. Okay, and all these are functional interfaces. So anything you can conceive that you need to manipulate data or manage data, there's a corresponding functional interface, and the predicate should be P is here. You see, represent predicate, returns a Boolean, taking one argument, and so those are things. You have one function, it takes one data type, returns another data type. Okay, takes one argument, returns something of this type. Take this type, returns this type. Okay, so you will also do double predicate. Okay, to two arguments, you return a Boolean. So consumer represents an operation that accepts one single input, returns no result. That's consumer. So all these, okay, so it's pretty complete. Okay, so you're going to see this supplier represent the supply of results. So here are some, okay, once you know this, those are just called functional interface. So I'm going to show you the predicates we just talked about, right? So let me go to predicate, click on this. The take you to the predicate interface is this, okay? Is a generic, okay? And there's only one method that's not implemented. These are all default or static, so they don't count. The only one that's not implemented, that's not default, not static, is a test. And it returns a Boolean. It takes one argument. In our example, it was a person argument, person object as the only argument. Right? Evaluate this predicate on the given argument. So it gives a Boolean. So that's one. So I just have one example for you. So I guess if I take more examples, then it will maybe even more confusing. Actually, I did two examples. One is comparator, one is predicate. Because both are used often. Actually, a lot of things used often. So we won't have time to go over every one of them. Okay, so basically, these kind of functional interface allow you to pass function as objects, as data, to any kind of methods you like. Like our example is search. Then allow you to delay the implementation. All right, so I hope you see the point of it. Okay, I hope you see that Java allows you to do something like this. This whole idea started with Java 8 a few years back. But when we were talking about interface, we didn't have so much time to talk about it. We did talk about the search, the predicate, but I don't think we put a lot of time specifically talking about function interface. We also talked about the definition of function interface, right? A interface has only one method, is not implemented. We did talk about the definition. All right, so if you have any question, we can address that. Anything? If not, then I'm going to change topic. Okay, I'm going to move into a new area, which is very powerful. So again, this is something we never had a chance to talk about, but I do want to fill in that hole. Okay, you're going to see that a lot. Good. Yeah, that's called streams. Okay, I'm going to show you the, I'm going to close all this and close all this, so I don't want to confuse you. Save, whatever. And that's stream. So I'm going to, first of all, tell you what that's about, right? So I'm going to show you a note here. I don't want you to read the whole entire thing because it's going to be too much. But okay, introduced the stream in Java. Introduced in Java 8. Okay, just follow me. We just read the part that that's important. Okay, this feature is introduced in Java 8. The stream API is used to process collections of objects. Okay, now is the right time to talk about it because we talked about data structures. We talked about collection framework, remember? Right, so this is the final piece we need to have to put a closure to collections. Okay, that's relatively new, started with Java 8. So here's a bunch of new APIs meant to process collections of objects. Okay, that means a group of objects. It's very popular now. It's highly regarded. Okay, what is a string? A string is a sequence of objects. Okay, it's a sequence, it's a group of objects, in other words. Okay, that supports various methods. Okay, so supports a bunch of methods. We're going to see those methods. Okay, those methods are specific methods, which can be pipelined. Pipeline means it's like a pipe, you can connect them. So one method will produce a string for another method, which produces a string for another method. That's called a pipeline. You connect them. Okay, so we have a bunch of methods can be kind of connected back to back. That's why it's so powerful. So why it's so popular. Okay, so to produce a desired result, the result could be anything. It could be one single value, could be another set of collection. Okay, so that's just the idea. So just you don't have to read this anymore. So what it means is take a collection of data, right? You turn that collection of data. Could it be array? Could it be list? Could it be queue? Could it be set? Remember those three things, right? Or could it be map? Okay. Now you take them and then you modify all the data in this collection and form a sequence of objects. So you take an array of objects, you form them into a sequence of objects. Okay, so once you have a sequence of objects, then you can pipe that, run those objects in one at a time, because it's a sequence, right? So you have to do one at a time through a series of methods, if you like. And those methods will allow you to manipulate the data one at a time. Okay, then you get a result. The result could be another data structure, another set of data after the processing, right? Or it could be just one number, okay, or one value, rather than a collection of data anymore. Okay, so give you an example. So I have an array. Right? Array has a bunch of, say, numbers. Okay, so first thing is I take the whole bunch of numbers in the array and form a string, form a sequence of numbers, number objects. Then I can take them one number at a time, the sequence, and accumulate them. To add them, get a total. So I return the total. So that's one simple example. Or I can take an array and I put them into a string, change the format into a sequence of number objects. Then I can take each number object. I want to only filter the numbers. I only pick up the numbers that can be divisible by 2. That means they're even numbers. Then I can form another list or another array or another set or another queue, whatever. And then I will return that. Or I can just print out them out. So that's another example. Okay, so there are many examples I'm going to show you. Okay. Now the features for the Java stream. A stream is not data structure. Okay, stream is not a independent data structure, so to speak. So when you have an array, when you turn that array into a stream, you're not really forming a new data structure. Okay, the original array is intact. The original array is still original array. You just temporarily modify it for a specific purpose. So the original array is not changed. It's still array. Even though you made a stream, it doesn't mean the array doesn't exist anymore. So the original array is still intact. Okay, so a stream is not data structure. Instead, it takes input. The input could be a collection. You know the collections. That means the set, the queue. Remember the list, or it could be an array. Okay, or it could be I/O. You don't even know what I/O. Well, you know, we know the stream, buffer stream. You know those input stream buffer. You know those. So we're gonna talk about I/O at some point, like for networking. So forget about that for the moment. So that, but now you just have to know you can take an input from collections. I mean set, queue, and map, and I mean list or arrays, and then you turn them into a stream. Okay, so stream is not data structure. Instead, it takes input from these to form a sequence of objects. Okay, you take data from a collection, from array, from I/O channels to form a sequence of object, right? All right. Streams do not change the original data structure. So if there was a set, it's still going to be a set. You're not going to change it. They only provide results as per the piped methods. They only provide methods, results after running through those methods, those pipeline methods or piped methods. Okay, you're not going to change the original data structure, in other words. If it was an array, it was array. It still remain an array. It was a set, remain a set. Okay. Now, each intermediate operation is lazily executed and returns a stream as a result. So many of the methods, when you run through them, they still return stream. You're not going to change to something else. Okay, you will see that what that means. Hence, various intermediate operations can be pipelined because they still maintain as stream. Okay. Now there's another type of operation called a terminal operation. So the two kinds. One's called intermediate operation. One's called terminal operations. Terminal operation marks the end of the stream. Okay, and returns the result. That's the terminal operation. Okay, intermediate operation does not return anything. It still maintains, just keeps still a stream. You don't return a result. You just still maintain a stream. Okay, so briefly, these are the commonly used intermediate operations. One's called map, one's called filter, one's called sorted. Those are three commonly used methods. Okay, the map is the one like this. See, there's a map. So, okay, I'm gonna show you how it works, right? First of all, you're gonna take a bunch of numbers as argument. You turn that into a list, which I showed you before. So this is nothing new. You take a bunch of numbers, you turn into a list. That means it's a subclass of the list interface, right? So that part is not new. Now the new part is here. See, the number is a list, right? That fulfills the collection definition, right? So you take a collection because list is a collection, right? And you run through the stream method. So dot stream. So what that means is you'll take whatever in the number, which is a bunch of integers, by the way. It's an integer object, really. 2, 3, 4, 5. And you turn those into a sequence of integer objects. The first one is 2, second one is 3, third one is 4, fourth one is 5. So now you have 4 objects in a stream. You can just imagine that, right? It's a series of number objects. 2, 3, 4, 5. They're all integer type. This is, I think, is a mistake. You should actually specify this is integer type because it only takes objects. String does not take a primitive. Okay, fine. Now, by doing this at this point, after I highlight this point, so we have a string. Means we have a sequence of integer object after finish the string that achieve it. Before that, it's just a list. After that is a string. So you always have to do string method to turn something into a string. Got it? So now I have a string. Once I have a string, I'm going to use the intermediate operation map. See this map method? Map. It takes what? Can you imagine what this takes? Can you imagine that what it takes? It takes a function. How do you know that? Because that's the lambda expression. But because it's a sequence of objects, so the x just means every object one at a time. So x means every single object one at a time in the string. The first object contains 2, right? Second object contains 3. Third one contains 4. The fourth one contains 5, right? So we do one at a time. We're going to map it out. How are we going to map out? We take the first value, which is 2. We turn that value into 2 times 2. So we did the square, right? So that means we turn 2 into 2 squared. So that formed the first object in the new string. And then we turn to the second object in the old string, which is 3. We do square. And do the third one, the fourth one. So in other words, we take every object in the first string, we square, and then we form a new string. So when I finish this, I have a new string. Inside the string, I have a sequence of object. Then the object are 2, 4, 9, 16, 25 now. Because I mapped out every single object into a new object, in the new string. See, we eliminated all the for loops we've been writing, or all those for each we've been writing. So far, we're still intermediate, right? So we still have a string, okay? Now, we have the collect method. Now, let's see what a collect method is. Collect method is a terminal operation. This is the time you're going to get a return, right? See, the collect method is used to return the result of the intermediate operation performed on the string. So the collect means we're going to return the new string, which is squared every number, right? We return that. So you see that? Return as what? Return back to a list. You see? So you take these collectors. Collectors is the new class. It has a static method called toList. So you return that new string into a list. You got it? So now what I'm going to do is I'm going to take this example. I'm going to copy this. And I'm going to actually implement it for you so you can actually visualize it. Okay, so here you go. So I'm going to do a new package. Okay, I'm going to say P3 demos. Okay, fine, demos. And then here, I'm going to create a demo. Okay, so I'm going to paste the things I did, right? So arrays, I'm going to import arrays as a util. Okay, so put a bunch of numbers, and it tells you change the number to integer. See, you should really have an integer. You cannot take as a primitive. So we should take this as integer. Okay, and then we're going to have to say it's the same thing. So it's an integer. This is integer. So now I have numbers. Okay, we'll import this as collector string. You see this import collectors. Okay, so now we have a new list because the string is now returned as a list. the new list will contain 4, 9, 16, 24, 25. Okay, so it means I take the original list that has 2, 3, 4, 5. Now I take that, I convert it into a string. Now I have 4 objects in sequence. I have 2, 3, 4, 5 in 4 separate objects, one each, and form a sequence. Now I'm going to map each object, take the value, and map to squared. Map to squared. So now, after I finish this one, I form a new string. The new string contains the squared value of the original string. Once I have the new string, then I will collect the results, turn this into a list. And that's why I can save it as a list. You should really even say this. Okay? And then now you can display the list and you can say square. Okay, so you should see 4, 9, 16, 25. Isn't that cool? Okay, so so we have other examples. Let me show you this since we're running out of time. Like the filter, right? So again, I have a bunch of same thing. Now I have a list of strings this time. You see the reflection, collection, string. Okay, this time, so I'm going to copy the same thing for you. Same thing here for you. And then I put this here. And then I have to say string type. Okay, and then this is string type. Okay, so now I going to display this. Sys out result. Okay, so what does this do is we're going to take the original array, which is a with a list. Actually, original is a list. See, we turn it into a list. The list contains 3 strings: reflection, collection, string. And now, after run the string method, I turn those 3 strings into a sequence of string objects. Okay, first one contains reflection, second one contains collection, third one contains string. Now I'm going to filter them this time. In other words, I'm going to cherry pick them. When I cherry pick them, I will take each string. I just come up with a random variable. I can call S or I can call anything I like. All it means is every single object. Okay, what are you going to do? You run it through a function. Remember function programming? What you do with that is you take that string and you can get only those strings because it's a filter. You can only get those things that returns true. That means the string starts with a capital S, because the string that starts with will return this one. That's the only one that matches that, right? So you're going to cherry pick only the one matches this, returns true. That means S. That's string. Okay. So now once you get that, that's a new string. But the new string has only one item inside. That's a string. That only one matches. And now you're going to collect that, put them into a list. So they call that list the result. So I'm going to print out the result. So if I do this, and then I only get a string. That's the only one matches. That's really cool. It's really cool. Okay. Right. That allows you to do that. So I know we're running out of time. Now the third one is sorted. Sorted. So I'm going to copy that, and I'm going to do one more thing. Okay. So here is string. Okay. And that's a string as well. And then we can disable the other ones. Okay. And now is we have a list contains reflection, collection, string, and then we're going to take the list. We're going to form a string. Okay, form a string. So then we can sort them. Okay. Now because you don't provide any arguments here, that means you're going to sort by what? you're gonna sort by the comparable, right? Which is means by its natural order. Okay, then once you sort them, you collect them into a list. So now you have a list. Okay, so now I'm going to display that result. So this will be the sorted version of this. So collection should come first, reflection second, stream third, right? So let's run that. You see, collection, reflection, stream. It's sorted for you. Okay, so this is just the return list. You could return set if you want to. So you can say return set. If you want to return set, then this has to be a set, obviously, right? This has to be a set. And then let's see, return change type result to set. That's a string, so we return a set. So now I can see if I can just do set like this, and that's the formatted version. That's the sorted version. So depending on how you want it, or you can see this finally. I know I'm running out of time. You can say for each. So you can print out each now. So if I have a set, rather than collect it, I can do something like this. I can comment this out quickly, and then I'm going to see if I can paste this. So I have a list, and rather than to a list, oh, I sorted, right? See, up to this point, I sorted, and I don't even need to get a result. So I take the name, I sort it. Now watch. For each, now you see the action consumer, does it function interface? Okay, so I can say for each number or S, whatever, then I can say sysout system dot out dot print line. See, so I'm going to print out each number from the string, and then that will give me reflection. The sorted version will print out collection first, reflection, then string. So now I run it. See, print out this way. So I can process each one of them separately, like that. So that's called a for each. Okay. Now finally, there's a new concept. I'm sorry, I just want to keep this. I want to show you another important concept we're going to talk about next time if you don't get it. So see, that's what I did for the function interface, right? See, that's a printout, right? So I can do something called method reference. Watch, it's crazy. System dot out, then colon, then print line. So this is equivalent to this. Okay, so the lambda expression could be written in this way. You don't even have to specify a variable. You just want to print out each number, that's all. So you're referencing a variable without providing the argument. Okay, so it will give you the same result. So if I disable this one, we just do the same thing. Yeah, keep it exactly the same thing. That's called methods reference. Method reference. That's a more concise way of doing number expression. So you don't need that dash greater than sign. You don't need this. You don't need a variable even, because the variable is arbitrary, right? We call n, we call s, we call whatever. It basically means each one of them, each one of the object. Okay, so all right, so that's you can see there's so many other things you can do. Maybe next time I can show you some other usage of this next time. Okay, so now we are closing up all the collections, how you process them. You know, finally the stream allow you to process them in very, very concise way. Right, because the string method can apply to any kind of collection or array or I/O channels. or IO streams. So once your data in data structure, you can already do a lot of things. You can do search by using the filter. You can sort in place. You can display. You can manipulate in place directly in one line, rather than writing all those for loops, while loops, and you don't have to do any of those anymore. You don't have a separate method to search. It's all in there. You see the filter, the filter. Where's my filter? Filter here. See, that's the search. And this is just a Boolean, though. You understand? This is the returns a Boolean. So I can have another Boolean there. I can say find the letters that's greater than A or less smaller than B or something. So you could do. So maybe next time we'll give you some other examples to show you how powerful this is. You eliminate all the need of writing separate methods. That means once you have a data structure, you can do whatever you want. You don't need separate methods anymore. So the whole back class we did in 148, which we put all those methods in, you remember? Display the method and the search methods and remove methods, they can be eliminated. We're back just to our original array or original collection. We don't need those backs anymore because the methods are here. See, we're back to 0. We just wasted all our time, a year's time. 148, we did all those backs, and 218, we did all this. Now it's all simplified. The key becomes data structure, becomes collections framework. Because once you have them, once you figure out what data structure to use, you can use a string. You can do whatever you want already. You don't need a separated methods. Isn't that crazy? Imagine this. You shake your heads, yes. So the final product of your work is so simple. All those methods is meant for you to learn how to code. Put a bag, abstraction, all that. Now we don't have to do those anymore, as long as we understand them. Right? You just need a demo. Whenever you need to hold data in the data structures. Then you need a demo. In the demo, last minute, whatever you want, you do it, stream. Right? So that's a 248. That's the last piece we want to fill of a knowledge hole. We couldn't talk about this in 218. We didn't have time. So I think it's a good idea to do this, and then now you feel like liberated almost, right? Okay, Jaleo, I think you had a question.
Yes, I was gonna ask. So just in other words, a stream is like you convert a data structure into stream, so that way you can have more options on what you can do on that data structure. Basically.
Right. You can search, you can display, you can displayed everything, right? You can filter, it's allow you to search. You can add stuff to it if you want to. Okay, use the method called off. There's an off method, I haven't talked about it. And you could remove things because you have a filter. You can remove things that doesn't meet the requirement. Right? All the things we did in the back class, we put so much effort in there to learn. Now it just takes one line rather than multiple methods.
But the complexity is the same, right?
The comparison is the same, yeah, because you still have to do the same thing. It's just like coding part becomes easier, right? So that shows you what's like in JavaScript. JavaScript is meant to be used this way. But it's very hard to learn it. It started with JavaScript because this is crazy. This is too much to learn the programming language. So Java led you slowly to this point. Okay. The key part is all this has to be functional. programming because you only have to have one result of each step, one set of result, and you equivocally one set of result. Right? You cannot be object oriented because object oriented based on the objects. The object changes, the result changes. That's crazy. You cannot do this. So this has to be always give you the same result if you have a data structure. Once you pipe it, it gives one result, one set of results only. So that's why it's functional. Everything returns one result that's always the same. So this provides you a good segue to like JavaScript or to some functional programming languages. There are some languages just like this that don't have methods. All they have is something like this. They pipe you through. Okay, those are called a functional programming language, as opposed to object-oriented programming languages. Earliest language is actually the functional languages. It's pretty amazing. Not object, like a Fortran is a functional programming language. And there's some really fancy ones nowadays. So we made this little transition. At least you get a taste of it. If we have time, we can talk about it more. And I will show you how powerful it is next time, maybe. Okay, this is just the introduction. And then if you want to look into it, you can always look into it. Bueno? All right.
Yeah,
so,
the Udemy course does do, she goes into functional programming, but it's not until you get into like databases that she really goes into it. Yeah,
yeah, that's she, right? So, but if you do JavaScript, if you learn the language alone, then you're gonna have to learn this early, right? But the way she organized it, yeah. But she's cool, right? Did you watch her? Did you guys watch her? She's cool. She's a good teacher. She works very nice.
talks a lot about best practice too. And she's like, yeah, you could just nothing but expressions, but the person after you might not know exactly what's going on.
Right. So by moving over from Java, then we all can find the corresponding things in JavaScript. Okay, that will help you understand the JavaScript much better. Right. All the concepts we learned in Java, like inheritance, polymorphism, classes, object, and now they all exist in JavaScript as well. But this is in Java is a lot more strict, a lot more comprehensive. So it's a lot more rule-based, right? So it's easy to learn as a first language. And once you have that, then you finish one language. Then other languages just variations of this, a different, slightly different syntax. Concept is the same. So congratulations. You finish one language. And the rest of the semester, we just add a few new things to the language. Then you can comfortably say that you finish the language. I hope you understood this, and then at least that's a good closure, right? You finish the language and the in and out, and we get to this point that things get actually simpler, right? Initially it was easy, and that was like 118, then gets harder, 148, and then 218, it gets okay on the plateau, and now it's like a fell off this cliff. It's so easy once you understand it. Right? You don't have to write all those methods anymore. You don't have to write all the bags anymore. Well, just put data into data structure and then run those stream and then do whatever you want. Right? Okay, same thing you can do for the Java FX and when you do search for things. Remember, you have all the names of trails. You can filter them too. Same thing. You don't have to write a separate methods and go back to do it. You can just filter them like this. Okay. By the way, when you do sort, right? You remember if you sort, this is just a array or this string, right? One more thing, I'm so sorry. I should mention this to you. I think it's so important. You see those lists is a bunch of names, right? That's a string. Because you already implement a comparable, right? You know that? That's how you can sort them, right? But what if you have a list of students or person or objects, right? Which do not automatically implement the comparable, correct? You may or may not. Say I have a persons. You may or may not implement comparable. Now here, when you try to sort it, you can bring in a comparator. Remember comparator? You can bring a comparator means I want to sort it this way, like a x, y as parameters, and then I can do this. Okay? Oh, because it's commented out. Okay, so basically what you can do is, so you can sort it. Remember this? You can return. That's comparator. So you can implement a comparator inside the sort as argument. The sort will take a comparator argument there. That's the part. The example is a little bit simplified because the integer is automatically naturally sorted by internally implemented comparable. But what about your project? What are your objects, like trails, like user profiles? How are you going to sort them, right? First thing is, of course, you can implement a comparable. You should. But what if you already committed to sort by one thing, now you want to sort by a different thing? Just create a comparator and put in the sort as argument. The sorted method as argument, I mean. Then you can sort it differently. As long as you understand what is comparator, it overrides comparable. So all the things we talked about the whole semester now are falling together into one piece. Because we're not just sorting integers, right? We're sorting objects, we're sorting trails, we're sorting user profiles. So when we wrote those classes, we should implement a comparable. If we want to implement a different, we want to do a different sort, then we can implement a comparator. Comparator we can put right into the argument of the sorted method, and we can sort it the other way, the new way, or different way. And a comparator is a functional interface, so we can implement that method in here, right in here, as argument, using lambda expression. Right, so I think, as far as I'm concerned, I think I finished. Okay, I explained everything, I think you need to know about data structures, about collections. But I don't know how much you were able to grasp because I went too fast. I went so fast. I tried to do systematically. I tried to do comparable. I tried to do comparator. I tried to show you the evolution of concrete comparator to anonymous class to lambda expression step by step. I tried to explain how to insert a functional interface into as argument, as object, as data. So I tried. Okay, so if you don't get it, maybe we can talk about it again next time. We're running out of time today. Okay, good. But I think it's fun, right? Programming is really fun. Remember what I said in 148? If you have this kind of mental inclination, it's actually fun because it's so rational, so logical, and then you can shape it the way you want. You can be very creative, right? You can be your own game, right? And then when you get it right, when you see the difference between the two versions of your program, from the backs we wrote in 148 versus this, and you realize that, you made a lot of progress. Yes? So That's why it's so interesting. Then you can save money for what? You can save money, you don't have to buy things to make you high because you can get a natural high here. Right? Cody? It's true. It's true. You don't need Adderall. You don't need any of those. You know, Adderalls. People go crazy to do those.
You mean Adderall?
Yeah.
No, that's for ADHD.
Well, not just for that.
Yeah.
A lot of people do that. Like elite schools because of the pressure.
Helps you focus.
Yeah.
Or helps me focus in my case.
Yeah, for you, yeah.
I had to use it for a long time.
Mm-hmm. So I think it's good. I think our schools are not as stressful as those schools. You have no idea how many people go crazy in those schools. I know a lot of them. Like people go to Harvard, you have no idea how sad to see them because the pressure they have. Because they want to be very successful, and then the pressure is incredible. They all, not all, many of them have a miserable life. But you guys don't have that kind of pressure. I always give you a lot of freedom. I never force you to do anything. I try to make this enjoyable, right? So we still cover the same material. Not bad. All right. So I hope you enjoyed. I see you next when? Today is Wednesday, next Monday. Okay. Most of you finished the assignment or no? Do you want me to give you another set? Or you want to finish that first?
I would say finish.
Yeah.
If you finish that one, then now you can implement a different. That's why I don't want to implement things first. I want you to figure out what to use first. Now you're ready to implement because you know stream, you know how to do collections.
Yeah, for sure. Thanks a lot.
I put
Gotta
a lot
go
of
work.
effort into this kind of thinking, when you should be doing what. I enjoy doing it, and I hope you enjoy it too. All right, so what's the decision? Should we have a new set, or you want to continue work on the previous one?
Continue working, I would say, for me at least.
What is it?
Yeah.
What is it?
I would say for me at least to continue working on the previous set. So now that I know streams, maybe I can implement that into that.
Well, do we want to take the data structures you worked on and then put it into a application now, or you still want to work on evaluating data structures?
Yeah. It seems like a lot of them. It seems like for a lot of them, I think trees are because you can't use hash because you can't have a set size. Arrays are just weird because the sorting is terrible.
Well, tree is good.
Yeah, but it's like it's
Yeah,
just trees within
Tree
trees.
set,
Trees.
tree set or tree map.
Yeah, that's what I was thinking
Mhm.
too. I
So tree
found
map allows you to have you need to have a key. Tree
yeah,
set, you don't have a key, but don't forget tree set. You have to have a comparable.
yeah.
Otherwise,
Basic-
you cannot compare. You cannot form a tree. In order to form a tree, you have to be compared, either by name of the trail, by length of the trail, or whatever you define in comparable.
Yeah, with
Right.
tree map, you can use a comparator, I think, or you can. Apparently, there's something called linked hash map, which keeps the keys in the order in which they were inserted. But I might just stick with tree map, even though apparently the linked hash is faster.
Tree set, you mean? Or tree map?
I
Tree
think.
map is a key as a value. Well, that's not a decision. Decision has to be data driven. So you have to feed the data. We did talk about how to create data, right? Remember the utility class? You have a static method to create data. So your program will neater because you create a random data for you to test things out. Right? Like emit trails, emit profiles. Right? Then you put an argument, if you emit like 1,000, 100,000, a million, so we'll just do it for you automatically. You know what I'm talking about? Utility class allow you to emit stuff in a very abstract way because it's hidden the complexity. When you use it, whenever you need a profile, just run the method. If you need a 10 method, just say emit a profile parentheses 10 or 100 or 1,000. So you put an argument in there. You guys okay? So you can organize your code better. So your demo won't be nearly as messy, right? Because the complexity is hidden in the utility class. So what do you think? You want to do new one, or you want to continue work on old one? But you do have to decide though. You have to make sure you conclude that which data structure is better to use. What data structures is the plural actually.
I'd like to keep working on the collections.
If you want to do that, that's fine. But just remember, right? When you ask for more time, every one of you, just make sure you do work on it. Don't just because you ask that you say, "Oh, I'm going to pull off another week." That's not going to help you. All right. So we may even use this as a like evaluation as part of your final grade. Maybe that if you need that kind of pressure or that kind of motivation. Otherwise, if you're not motivated, right, then maybe you don't do anything. Then in the end, you have nothing to submit, and then you set up yourself up as a failure in the end. Yes. So you want one more week, or just like a half a week, Monday maybe? Or I just give you another set for you to continue. I give you another set. Then make you feel bad, so this way you're further behind. Right? All right, just make you feel bad. I'll give you another set this week, sometime this week, tomorrow or something. Okay? So this way I give you a little pressure. But don't jump off the building or something. It's not the end of the world. Okay? All right, so I see you then next week. Enjoy the weekend. Good. Adios. Bye.
That's good.